Hello everyone and welcome to the lecture on AWS Glue DataBrew. So this lecture will contain all those topics. What is AWS Glue DataBrew? Core concepts, project, dataset, recipe, job, data lineage, data profile, AWS services for networking, management and governance integration, AWS data lakes and data stores integration, supported file formats and file types, and supported recipe types. So what is AWS Glue DataBrew? AWS Glue DataBrew is a visual tool that helps you clean and normalize your data without having to write any code. It is great for everyone, no matter their technical skill level. Using DataBrew, you can reduce the time it takes to prepare data for things like analytics and machine learning by up to 80% compared to writing your own custom code. You get to choose from over 250 pre-built transformations to automate common data preparation tasks, and this includes things like filtering out strange data, converting data to a standard format, and fixing values that are incorrect. Because DataBrew is serverless, you can work with huge amounts of raw data, even terabytes in size, without ever needing to create a cluster or manage any infrastructure. The tool has an intuitive interface that makes smart suggestions to help you find data quality problems that can really be hard and time-consuming to spot on your own. You can save all of your transformation steps into something called a recipe. You can then update this recipe or reuse it later on other sets of data, making your work faster and more consistent. So core concepts. So these are project, dataset, recipe, job, data lineage and data profile. So first one is the project. The project is the interactive data preparation workspace in DataBrew, and this is called the project. Using a data project, you manage a collection of related items like data, transformations, and scheduled processes. As part of creating a project, you choose or create a dataset to work on. Next, you create a recipe, which is a set of instructions or steps that you want DataBrew to act on. These actions transform your raw data into a form that is ready to be consumed by your data pipeline. Next important concept is dataset. A dataset simply means a set of data rows or records that are divided into columns or fields. When you create a DataBrew project, you connect to or upload data that you want to transform or prepare. DataBrew can work with data from any source, import it from formatted files, and it connects directly to a growing list of data stores. For DataBrew, a dataset is read-only connection to your data. DataBrew collects a set of descriptive metadata to refer to the data. No actual data can be altered or stored by DataBrew. For simplicity, we use dataset to refer to both the actual dataset and the metadata DataBrew uses. Next important concept is recipe. So in DataBrew, a recipe is a set of instructions or steps for data that you want DataBrew to act on. A recipe can contain many steps, and each step can contain many actions. You use the transformations tools on the toolbar to set up all the changes that you want to make to your data. Later, when you are ready to see the finished product of your recipe, you assign this job to DataBrew and schedule it. DataBrew stores the instructions about data transformation, but it does not store any of your actual data. You can download and reuse recipes in other projects as well. You can also publish multiple versions of a recipe. The next important concept is job. DataBrew takes on the job of transforming your data by running the instructions that you set up when you made a recipe. The process of running these instructions is called a job. A job can put your data recipes into action according to a preset schedule. But you are not confined to a schedule. You can also run jobs on demand. If you want to profile some data, you don't need a recipe. In that case, you can just set up a profile job to create a data profile. Next important concept is data lineage. The DataBrew tracks your data in a visual interface to determine its origin, called a data lineage. This view shows you how the data flows through the different entities from where it originally came from. You can see its origin, other entities it was influenced by, what happened to it over time, and where it was stored. And last, we have data profile. So when you profile your data, DataBrew creates a report called a data profile. This summary tells you about the existing shape of your data, including the context of the content, the structure of the data, and its relationships. You can make a data profile for any dataset by running a data profile job. So this is the complete picture, and it includes all the core concepts. So AWS services for networking, management, and governance integration. So these are the services which integrate with DataBrew from a networking, management, and governance point of view. And these are CloudFront, AWS CloudFormation, AWS CloudTrail, Amazon CloudWatch, AWS Step Functions, and AWS Data Lakes and Data Stores integration. So these are directly integrated with DataBrew, and these are Lake Formation and Amazon S3. So these are supported file formats and file extensions and the compression extensions. So we have CSV file, which is .csv, but if you compress, it will be gz, .snappy, lz4, bz2, or deflate. So it basically means DataBrew can automatically, you can point DataBrew to this kind of file, and it will figure out what is the content, and based on the extension and based on the content of the file. Then you have Microsoft Excel workbook, which is Excel SX, and there is no compression support. Then JSON document and JSON lines. So this is .json and JSON-L, and compression extensions supported are gz, snappy, lz4, bz2, deflate. So these are same. Apache ORC, which will be .orc, and compression extension is .zlib or snappy. And Apache Parquet, if it is compressed, it will be gz, snappy, or lz4. Next is file extensions which are uncompressed and file extensions compressed. So for example, .csv, so you can have .csv.snappy, .csv.gz, .csv.lz4, .csv.bz2, .csv.deflate, and .csv.br. So this will figure out based on the extension what is the actual content and how it was compressed based on the last extension. Then if it is tab separated values .csv, so it can be tsv.snappy, tsv.gz, lz4, bz2, and so on, the deflate and br. Then Parquet, we have Parquet.snappy, Parquet.gz, Parquet.lz4, Parquet.lzo, and Parquet.br. Then Glue Parquet, it's not supported, but file extensions compressed is Glue Parquet Snappy. Apache Avro is .avro, and if it is compressed, avro.snappy, avro.gz, lz4, bz2, deflate, and br. For ORC, it will be orc.snappy, lzo, and zlib. XML is again snappy, gz for all the same contenders. Then JSON again snappy, gz for same set of compressed file extensions type. Then Tableau Hyper is not supported. Next is the all the recipes that it supports. So basically high level kind of recipe. So you have basic column recipe, you can have filter and column aggregations and all. Then data cleaning recipes like format, clean, extract. Data quality recipe steps, and you have like missing data, invalid data, any duplicates, and outliers. Next is personally identifiable information. This is PII recipe steps. So you can have mask personal information, replace personal information, encrypt personal information, or shuffle rows. Then column structure recipe steps, you have split, merge, and create. Then column formatting recipe steps, so you have decimal precision, thousand separator, and abbreviate numbers. So basically looking at the column, you can perform all these steps, all these recipes. Data structure recipe steps, so you have nest, unnest, you have pivot, you have group, you have join, and union. Data science recipe steps, you have text analysis, scaling, mapping, and encoding. And some recipes related to functions are mathematical functions, aggregate functions, text functions, date and time functions, window functions, web functions, and some other functions as well. And that's all. Thanks for watching.